Hello, welcome to 2.2 Linear Equations in One Variable. So this video and the examples and information contained in this section do refer to information from the OpenStax College Algebra textbook. And you can see at the bottom there is the link to that. So if you want to type that in and get to the textbook, you can. So in this section, we're going to be talking about linear equations in one variable. We're going to do several things with this. So let's start at the top. Let's start at the very basic, how to solve a linear equation in one variable. So for number one, if you have one variable, you can see it's just x, right? You have x only, and it's not raised to any power. So it's not like x squared or x cubed, it's just x. That is a linear equation, and since there's only x, it's one variable. What we're going to do is try to get the x by itself. So that is your goal when you're solving an equation, is to get the variable by itself. If you have variables on each side, your goal is to get all the variables on one side of the equal sign and everything else on the other side of the equal sign. So just out of habit, I like to move my variables to the left, but you can move it either way you'd like. So I'm going to subtract 3x from both sides because that will zero out on the right-hand side, and then my x's will be gone. And on the left, I can combine them to get 4x, because 7x minus 3x is 4x. I'm going to use that same idea for the constant terms, so the things without a variable. So I want to move everything without a variable to the right. So to undo this plus 2, I'm going to subtract 2. I have to do the same thing to both sides of the equal sign to keep it balanced. On the left-hand side, the 2 and the negative 2 cancel out. And on the right-hand side, I can simply combine my like terms. So negative 9 and negative 2 is negative 11. All right, so now I have x's on the left, constants on the right. So I'm going to continue to solve. To get the x by itself, I need to get rid of the 4. Since it's multiplication, I undo that by dividing. So I'm going to divide both sides by 4. When I do that, the 4's divide out to 1, so I get x equals negative 11 over 4. Now that fraction will not reduce, so that's in lowest terms. So that is my solution. All right, so don't be freaked out if you get a fraction that doesn't reduce. It doesn't always have to be a number, like a whole number, to be a valid answer. Get used to seeing fractions, okay? The other thing is you don't always need to turn those into mixed numbers. So I know a lot of times when you're in like middle school and junior high and high school, they tell you to always change to mixed number. That's not the case. We usually want you to leave it as an improper fraction. So just leave it right there. Make sure it's simplified, but leave it right there. All right, number 2. So it's similar, a little bit more complex. So we're going to start by getting rid of the parentheses on the left. So you want to distribute this negative 5 to both things in the parentheses. So when you do that, you're going to bring down the 12, then minus 5x minus 15. So negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. Equals, bring down the stuff on the right, so 2x minus 5. Now what you want to do is combine any like terms on each side of the equal sign separately. So on the left-hand side, I have 12 and I have a negative 15. So since both of those are constant terms, I can combine those together. So I'm going to have negative 5x. Oops. Let's try that again. Negative 5x. 12 minus 15 is negative 3. Bring down the stuff on the other side. Now we have an equation that looks very much like the one that we had in number 1. So we're simply going to move the variables to one side and the constants to the other. So to move the x's to the left, I need to do the opposite. So since I have a positive 2x, I'm going to subtract 2x. Okay. And so that will cancel out on the right-hand side. And then for the constant, since I have a negative 3 on the left and I want that to cancel out, I'm going to add 3 to both sides. So now the negative 3 and positive 3 will cancel on that side. So negative 5x minus 2x is negative 7x. Negative 5 plus 3 is negative 2. The last step here is to get the x by itself. Since it's multiplying negative 7 times x, I'm going to undo that by dividing by negative 7. And so I will have x equals 2 negatives make a positive. So this will just be 2/7. So negative 2 divided by negative 7 is a positive 2/7. Again, this fraction is in lowest terms because the 2 and the 7 do not have any common factors. So that's it. Okay, so number 3. We're going to talk about rational equations now. This means you're going to have fractions within the equation that you're going to need to get rid of. This is kind of the simplest case, and then we'll see more complicated cases as we work through this section. Here is the way you're going to solve these. So first, you want to make sure all denominators are completely factored. In number 3, this is already done because we have only one term in each denominator. The second thing is you're going to find and exclude values that set each denominator equal to 0, and we can kind of come back to number 2. So that's something you can do at the end, which is usually what I do, but you need to make sure you come back to that. Number 3, you're going to find the least common denominator. So for 3 here, the least common denominator, and you have to look on all the fractions, both sides of the equal sign. You have an x, a 3, and a 6. So first you want to look at your numbers. So 3 and a 6. The least common denominator is going to be 6. And then you have to include the variable as well. So your least common denominator is 6x. Now what you want to do is multiply the whole equation by the LCD. If you have it right, then all of your denominators will cancel out and you will not have fractions anymore. That's the goal, get rid of the fractions. So let's see if that's the case here. So we have to multiply each side of the equation by 6x to keep it balanced. And what we're going to do is we're going to distribute that on the left-hand side because there are two terms. On the right-hand side, there's only one. So let me show you what that's going to look like. We have 6x times 3 over x minus 1/3 times 6x over 1 equals 1/6 times 6x over 1. So notice that everything I wrote in black is the original equation, right? That's what we were given. And the lime green is what I'm multiplying by, right? So all I did was distribute the 6x to every term. And now I'm going to see if it all cancels out. So if I look at the first term, 6x and x, the x's cancel out. And so I will be left with 6 times 3. So this first part gives me 18. In the second part, I have a 3 in the denominator and a 6x in the numerator. So the 3 will become a 1, the 6 becomes a 2, because those are both divisible by 3. So 3 divided by 3 is 1, 6 divided by 3 is 2. So now I will have minus 1 times 2x would be 2x left from that part, right? Notice that all the denominators have canceled out. They're all 1s, so there's not a denominator anymore. Okay, so now I have equals, the equals over here. Now I want to do this part. So the 6 and the 6x, the 6's will divide out into 1s. So I have 1 times 1x left, which is just x. Okay, so find the least common denominator, multiply the whole equation by that, cancel it out with the denominators, and see what you have left. So we now have 18 minus 2x equals x. So I'm going to rewrite that up here so I have more room to work. Okay, now my goal is to get my x's on one side and my constants on the other. I'm going to go ahead and add the 2x this time, simply because it will be less steps. So I'm getting rid of the x on this side. So I'll have 18 equals 3x divided by 3, so x equals 6. Now, this is a proposed solution. Okay, we think it's a solution. Before we can say for sure that it is a solution, we have to go back and look at the denominators. So, this is step 2 and step 6. So we're looking at all of the denominators. You only have to worry about the denominators that have a variable in it, because you're not going to plug your answer into a denominator with no variable. So the only denominator we have to worry about, even though I highlighted 3, is the x. So we want to know, if we plug in 6 for x, is that going to give us a 0? No, it will not. So if it doesn't give us a 0, this is a valid solution. Okay? If we would have gotten 0 here as an answer and we tried to plug that in, that would have given us a 0 on the bottom, so that would not have been a valid solution. Okay? So 6 is our answer. All right, let's look at some more. So you can see number 4 and number 5 are going to be similar, but they're more challenging, right? Because now instead of just having one term on each denominator, we've got binomials, and then number 5, a trinomial. All right, so let's start walking through the steps. So the first step is to make sure every denominator is fully factored. So in number 4, x minus 2, that's factored. X minus 1, that's factored. And the last fraction is x minus 1, x minus 2. That is also factored. If you go ahead and look at number 5, you can see the difference in the last fraction. The x squared minus 2x minus 3 is not factored. That's where you're going to have to factor if it looks like that. But for number 4, it's all factored. So the first step is done. So now what we want to do is determine the LCD. So the LCD, to find the LCD, you include each unique factor raised to the greatest power that appears in any factored denominator. So each unique factor. So even though there are not parentheses around this, those are together as one factor. Same here. So we're going to look and include each unique factor. So the first factor we see is x minus 2. So we need to include that in the LCD. The second factor we see is x minus 1. Notice I'm not saying x, because x is not by itself. X is attached to the 1 with that minus sign. So x minus 1 comes together as a factor. That is different than x minus 2. So we have to include that factor. Now if we look at the third denominator, we have x minus 1 is one factor, and x minus 2 is a second factor. So that denominator has two factors. Are either of those unique? No. We've already included x minus 1, and we've already included x minus 2. Those are already written in our LCD. So since they're not different, we do not write those down again. So our LCD is x minus 2, x minus 1. So now we want to multiply each fraction by the LCD. So I'm going to erase those to make it easier to see. And I'm going to multiply every fraction by the entire LCD. So this one is going to be multiplied by x minus 2, x minus 1, x minus 2, x minus 1, x minus 2, x minus 1. Okay, so you see how there are three distinct fractions? Each fraction gets multiplied by the entire LCD. Now your goal is to cancel out anything you can with the denominator. So in the first fraction, the x minus 2's cancel, and that leaves us the 3 times x minus 1 equals, okay? Now the second fraction, we can cancel out the x minus 1's, and so that leaves us 1 times x minus 2. Okay, now we have a plus. From the third fraction, we actually can cancel everything out, right? So the x minus 2's cancel, the x minus 1's cancel, so that simply leaves us a 7 from the third fraction. Notice that everything from the denominator is canceled out. If that does not happen, then you did not pick the correct least common denominator and you need to start over. So if everything does not cancel out, you did not pick the right LCD. You need to start over. But in our case, everything did. So now we're going to move forward. Now we simply have a linear equation in one variable with no fractions. So we don't have a rational equation anymore. So we're just going to solve it. We're going to get rid of the parentheses first. So distribute the 3 here, distribute the 1 here, and that gives us 3x minus 3 is equal to 1x, which is just which is just x, and minus 2, bring down the plus 7. We now have like terms on this side, so we're going to combine those. So we'll have 3x minus 3 is equal to x plus 5, because negative 2 plus 7 is 5. We're going to now move the x's to the left and the constants to the right. So minus x from each side, plus 3 to each side. And that leaves us with 2x plus 8. And not plus 8, equals 8, right? It should be equals 8. Now we have equations, so if you don't end up with an equation, you clearly did something wrong as well. So 2x equals 8. Okay, that looks better. So now we want to get the x by itself. So we're going to divide both sides by 2. So x equals 4. Now remember, it's going to be very tempting to just box that in and say that's your answer. But you have to check your LCD, okay, or your factors on the denominator. Make sure it doesn't make anything 0. To me, the easiest thing to do is just check your LCD. If it makes any factor 0, then it does not work. Okay, so I'm going to check here, and I'm going to check here, because this represents all the unique factors in your denominators. Okay, so 4, if I plug in 4, so let me bring those arrows down a little bit. Okay, if I plug in 4, 4 minus 2 is 2. That's not 0. 4 minus 1 is 3. That's not 0. So since I don't get 0 in either case, 4 is a valid solution. All right, so let's look at number 5. Same steps. One extra step, however, this time is that we have to factor that last denominator. So x plus 1 is factored. X minus 3 is factored. Remember, if you need to, you can put the little parentheses to remind yourself that those are together as a factor. And now I need to factor this last denominator. So x squared minus 2x minus 3. So remember to factor this trinomial. You're going to put 2 sets of parentheses. Your x squared is going to break up into x and x. You want it to multiply to get negative 3 and add to get negative 2. So that will be negative 3 and positive 1. That will multiply to get negative 3 and add to get negative 2. So now we're not going to be using that anymore. We're going to be using those factors. And notice that the factors are the same as what we already have on the left-hand side. So a lot of times it'll work out that way just so your life will be easier. They're kind of manufactured to work that way. So if you don't get the same thing, it doesn't mean you're wrong necessarily, but you might want to just double check your work, okay? All right, so I'm going to find the LCD. So the LCD, we have to include each unique factor. So x plus 1 is the first factor I see, so I have to include that. The next factor I see is x minus 3. Well, that's different than x plus 1, so I've got to include that. And then in the last fraction, I see x minus 3 and x plus 1, but I have already included both of those in my LCD, so I don't need to write them down again. So my LCD is x plus 1, x minus 3. Now that I've determined my LCD, I'm going to multiply each fraction by the entire LCD. So x plus 1, x minus 3, x plus 1, x minus 3, and x plus 1, x minus 3. Okay, and I'm going to start canceling out. Remember, if all of your denominators do not cancel out, you did something wrong. So in the first fraction, the x plus 1's cancel. And from that, I am left with a 5 times x minus 3. Bring down the plus. From the second fraction, I can see that x minus 3's cancel. And from that, I am left with a 1 times x plus 1 equals the very last fraction. All of the denominators cancel with the factors that we multiplied by. So I am left with a -6. All right, now we're going to solve it like we did the last one. So distribute the 5, distribute the 1. So we will get 5x minus 15 plus x plus 1 equals -6. We're going to combine our like terms. So we have 5x and positive x, so those are like terms. And then we have -15 and positive 1. So those are all on the same side of the equal sign. So I'm going to just simply combine them together. So 5x plus x is 6x. -15 plus 1 is -14 equals -6. So notice I didn't undo anything or use the opposite sign. It's because all of that stuff is on the same side of the equal sign. So you're just going to combine your like terms. Once you do that, then you start undoing things. So at this point, we can see that our x is on the left. So we need to move the 14, the -14, by adding 14 to both sides. So that cancels out from the left. So we'll be left with 6x is equal to 8. All right, now the last step is to divide both sides by whatever is in front of x. So we're going to divide by 6. So that's going to give us x equals 8 over 6. Now, here's a fraction. We want to make sure that we reduce. So we can divide by 2, we get 4 over 3. So x equals 4/3. Okay, so the last step is to check. Is 4/3 going to make either of these 0? If we plug in 4/3, we will see that they are not 0. So this is a valid solution. Again, what you're looking for is if it makes it 0. So let's say, so we're going to play pretend here. Don't get confused. I'm just making this up. So this is totally separate. Let's say we solved an equation. Okay, here's all the work we did. And we ended up with x equals 3. Okay, so let's just say we got that. And then I wanted to check it in the LCD. If I plugged in 3 for this second part, I would get 3 minus 3, which is 0. That would be not valid, so that would not be a valid solution. And if that was the only proposed solution I got, it doesn't check, then I would have no solution. Okay, so be on the lookout for that. If you find an answer that you think, like here we thought, oh, x is 3. If you plug it in and it doesn't work, i.e. you get 0, then you have no solution. Okay? If for some reason you get more than one solution and one of them checks and one of them doesn't, then you'd only have one solution. And we'll see more like that later. Okay, but anyway, the green has nothing to do with the previous example. Remember, I just made that up to show you what you would do if it does not check. Okay, so let's get to the next part. So the next part of this section is about having a slope of a line. So the slope of a line represents the change in y over the change in x. So given 2 points, the following formula determines the slope of a line containing these points. So the very first part was just solving linear equations in one variable. Now we're at linear equations with 2 variables. We're using x and y. So this is the second part of this section. So to find the slope, you're simply going to use the formula given in this box. So I just generally use the first point as my 1's, so x1, y1, and the second point as my 2's, but remember that you can interchange those. You just have to be consistent. So x1 and y1 have to go together. All right, that being said, our slope, we simply plug stuff in. So 9 minus 4 over 7 minus 5. So that would be 5 over 2. So for the slope here, we'd have 5/2. Okay. For number 7, same thing. We would have 4 minus 4 over 2 minus a negative 5. So that would be 4 minus 4 is 0 over 2 minus a negative makes a plus. So 2 plus 5 is 7. 0 divided by 7 is 0. So if 0 is on top, it's okay, and you get a 0. Okay, so here the slope is 0. Let's compare that with number 8. So here we'll have 3 minus a negative 1. So instead of doing minus a negative 1, I just skipped to plus 1. And 2 minus 2. So that's going to be 4 over 0. This is going to be undefined. Okay, so if 0 is on top, it's okay. So one of my professors showed me this before. 0 on top, it's okay, you get 0. 0 on the bottom is a no, that's undefined. All right, so you need to memorize the difference between those two. So a 0 on the top is okay, it's 0. A 0 on the bottom is a no, it's undefined. These are for special cases. So if you get a slope of 0, this is going to be a horizontal line. So it looks like this. Okay? Horizontal line always has a 0 slope. Okay? If you get an undefined slope, that's always going to be a vertical line. So vertical lines always have an undefined slope. Make sure you know that information. All right, let's see. Slope-intercept form of a line. So this is y equals mx plus b. This is the most common way to see a line written. So the m is the slope, okay, and the b is the y value of the y-intercept. So this form is very useful because if you have it written like this, you know where it crosses the y-axis with the b, and you know at what rate it increases or decreases with the m, the slope. So for the next two, 9 and 10, we're going to identify the slope and the y-intercept based on the equation. So look at number 9. It's already in the slope-intercept form. So the number in front of the x is your m, and your constant is your b. So let's see how to write these. So your slope is -2. Your y-intercept is an ordered pair. It's going to be 0, 3. So what's in blue is the y value of the y-intercept. And remember, a y-intercept is an ordered pair. So it will be 0, 3. The x value is always 0 for a y-intercept. All right, number 10. So I put this one on here because this is kind of tricky sometimes. So the slope is in front of x. So what is in front of x? Nothing is written there. But remember, it's understood to be a 1. So your slope is 1. And then the y-intercept. What is added or subtracted after the x? Nothing, right? So that means I could think of it as a plus 0. If I add 0, it does not change anything for the equation. So the 0 is actually the b. So the y-intercept would be 0, 0. So if there's not a constant added or subtracted, it's understood to be a 0. So your y-intercept, in that case, would be 0, 0. All right. Standard form of a line. So there's different ways to write a line. Another way to write a line is in standard form. It's when you have your x's and your y's on the left and your constant on the right. Example number 11 starts off in standard form. We want to find the slope and y-intercept of the line, so what we want to do is rewrite it in slope-intercept form, which means solve for y, and then we can see the slope and the y-intercept from there. Okay. So to do that, you're going to isolate the y. So we want to get the y by itself. So we'll start by subtracting 2x from both sides. So when we do that, those will cancel out and we'll get negative 3y is equal to negative 2x plus 5. And to finish getting the y by itself, we're going to divide by negative 3. So that's going to be y equals negative 2 divided by negative 3 is positive 2/3 x. 5 divided by negative 3 is minus 5/3. Okay, so whatever is in front of the the x, the y is by itself, whatever's in front of the x is your slope, and whatever is the constant is your y-intercept. I might have mixed up the colors from above, but slope is 2/3, and the y-intercept is 0, negative 5/3. Okay? So if your line is not given in slope-intercept form, change it to that form so that you can easily find the slope and the y-intercept if you need that information. All right, so last we have the point-slope form of a line. This is very important when we're given different pieces of information. So you need to make sure you have this memorized. You need to have all the formulas memorized, but I would say most students know the y equals mx plus b. But a lot of students don't have this formula memorized. So you need to make sure you make a note of this form. It's point-slope form. You're going to use this when you're given a random point and a slope, or two random points. And you'll see that as we work through these next examples, when to use this formula. Okay, so for the next ones, we want to find the equation of the line using the given information. Write all the final equations using slope-intercept form. So for number 12, we want to really look at what we are given here. So we're given a point and we're given a slope. Now, since we're given a point and a slope, we could use the point-slope form. But look at what point we're given. We're not just given any point. We're given a y-intercept. And we know it's a y-intercept because the x value is 0. That's how we know it's a y-intercept. Okay? So this is a y-intercept. And we're given a slope. If we have a y-intercept and a slope, this is actually the best case scenario because we have the m and we have the b. So we have y equals mx plus b. We're going to go directly to our slope-intercept form because we were given those pieces of information. So the slope is 2/3 and the b is 3. And so you're done. That is like the easiest one you could possibly get. So look to see if they gave you the y-intercept. If they did, use this little shortcut. Now let's look at number 13. Number 13 at first looks the same as number 12. They give us a point and they give us a slope. But look at the point. This point is not the y-intercept because this x value is not 0. This is a random point. And you know it's a random point because the x is not 0. So if they're giving you a random point, you need to use the point-slope form of a line. Okay, so this is how you know to use this point-slope form instead of jumping directly to the slope-intercept form. So that's going to be y minus y1 equals m times x minus x1. Now here's the key. The y and the x, the plain y and the plain x, do not get anything plugged in. The y sub 1 and the x sub 1 are going to take the numbers from the coordinate pair, okay, from the ordered pair, and then the m is going to take the number from the slope. So that is going to look like y minus y sub 1 is 5 is equal to m, which is negative 2, times x minus x sub 1, which is 1. All right, so now we're going to distribute the negative 2. So we'll have y minus 5 is equal to negative 2x plus 2. Now we want to finish getting the y by itself, so we're going to add 5 to both sides. So I will get y equals negative 2x plus 7. And that's what it asked us to do. Write the final equation using the slope-intercept form. So there it is. All right, so that's how you work it out if you're given a random point and a slope. Number 14, we're going to have the same directions. This time it's giving us 2 points. So you have to have a slope in order to use any of the equations or forms of a line that we've been given. So your first step is to find the slope. Okay, so it's not going to tell you that. You're going to have to know that. So if you're given 2 points, your first step is to find the slope. You need to have the slope formula memorized. Remember that it's y2 minus y1 over x2 minus x1. So let's see, we'll have negative 6 minus 10 over 5 minus a negative 3, so 5 plus 3. So that's going to be negative 16 over 8, which is negative 2. So there is our slope, okay? Now I have a slope and I have a random point. It doesn't matter which point you just use whichever point you want. So here's our slope, and I'm going to use, let's use this one. It doesn't matter which point you use, I'm just picking one, okay? So I'm going to use my slope and my point in the point-slope form. Oops. So that's y minus y1 is equal to m times x minus x1. And so now we're going to have y minus a negative 6, so it's going to end up being plus 6, the two negatives will make a plus, is equal to m, which is negative 2, times x minus x of 1 is 5. Now I want to distribute the negative 2. All right, so we have y plus 6 is equal to negative 2x plus 10. The last step to get the y by itself is we're going to subtract the 6 from both sides. So that'll give us y equals negative 2x plus 4. And there is our equation in slope-intercept form. So that is how you do that if you're given 2 points. All right. So the next thing we need to talk about are parallel and perpendicular lines. So parallel lines have the same slope. Parallel lines, okay, run in the same direction, have the same rate of change, so they never intersect. So they have the same slope. So those are parallel lines. Okay, perpendicular lines intersect at exactly a 90-degree angle. So they intersect and create a 90-degree angle. If they're neither parallel nor perpendicular, they intersect, but not at a 90-degree angle. So they're just intersecting lines, okay? So if they're parallel, they have the same slope. If they're perpendicular, they have opposite reciprocal slopes. Remember, reciprocal means the fraction is flipped. So they're going to have different signs, and it's going to be flipped. So let me just show you a quick example. Let's say for parallel lines, the first slope is 1/2, and the second slope is 1/2. Those would be parallel. For perpendicular lines, if the first slope is negative 2/3, then the second slope would be positive 3/2. So see, the signs are different. That's the opposite part. And they're reciprocals in that they're flipped. The first one is 2/3. The second one is 3/2. That would be perpendicular. The neither just means that it's neither of those cases. So for example, the first slope could be 2 and the second slope could be negative 8. Okay, that's neither parallel nor perpendicular. So let's look at what we're going to do with that information. So given the two linear equations, decide if the lines are parallel, perpendicular, or neither. What they're really asking you to do is look at the slopes and compare the slopes. So in order to compare the slopes, we need to get it in slope-intercept form. So we're going to start by subtracting 3x from both sides. Remember, that means we want to get the y by itself. So negative 2y is equal to negative 3x plus 5. Divide by negative 2. So y is equal to 3 halves x minus 5 halves. The only thing we care about in this situation is the slope. So we are looking at the slope. All right, so 3 halves is the slope of that one. And for the second one, we're going to add 9x to both sides. So we get 6y is equal to 9x plus 6. Divide by 6. So y is equal to 9 over 6 is going to reduce to 3 halves. So 3 halves x plus 1. Again, we're interested in the slope. The slope is 3 halves. So notice that here we have the same exact slope. So that means that these lines are parallel. All right, that's all we had to do for that. So now let's do the second example. We have to solve for y, so we're going to add 2x to both sides. So y is equal to 2x plus 7. So the y is by itself, so 2 is the slope. All right, if we look at the second one, that one is already solved for y, so the slope is negative 1/2. So if we compare these, we have 2. Remember, 2 is the same as 2 over 1. So we have 2 over 1 compared to negative 1/2. Well, they're different signs and they're flipped. They're reciprocals. So these are perpendicular lines because they're opposite reciprocals. Okay. The last part of this section, we're going to find the equation of the line using the given information, and we're going to write our final answer in slope-intercept form. Okay, so if we know that we have a line that is parallel to the line y equals 2x plus 5, and we know that it passes through the point 4, 3, we want to write the equation for that line. So what we want to look at is if the lines are parallel, that means they have the same slope. So since the lines are parallel, our slope is going to be 2. That is all we care about from that equation. That is literally the only piece of information we're getting. And now we don't care about this at all. Okay, so this is done. All we care about is the m equals 2. So now we're going to use m equals 2 and the point and use the point slope form of the line. So the point slope form of the line, you have to remember that equation is y minus y1 equals m times x minus x1. We're going to plug in what we have. So y is 3, m is 2, and our x is 4. We're going to distribute the 2, so we'll have y minus 3 equals 2x minus 8. Add 3 to both sides. So the 3's cancel out on the left, and we get y equals 2x minus 5. And that is our equation. All right, so let's look at number 18. So for 18, it's perpendicular to the line 3y equals x minus 4 and passes through the point negative 2, 1. So remember, if you have parallel or perpendicular to, all you're doing is using that equation for the slope. So to find the slope, we need to get the y by itself. So y equals 1/3 x minus 4/3. So the slope is 1/3. But our lines are not parallel this time, they're perpendicular. So remember that perpendicular lines have opposite reciprocal. So for my slope, I'm going to have to use the opposite sign. So that's a negative because the slope for this equation was positive. And we're going to flip it. So it's going to be 3 over 1 or 3. So this is the slope that we want because we have a perpendicular line. Okay. So now we don't care about any of that. We're going to use m equals negative 3 and the point negative 2, 1. And we're going to use our point slope form. So y minus y1 equals m times x minus x1. So y minus 1 is equal to negative 3 times x minus a negative 2. So the minus a negative makes a plus. Distribute the negative 3, so y minus 1 equals negative 3x minus 6. Add 1 to both sides. So we have y equals negative 3x minus 5. And that's the equation of the line that's perpendicular to the given line and passes through the point negative 2, 1.